Okay, in this video we're going to work through some chapter review questions for financial maths or financial arithmetic. In question 1, Anthony earned $1,016 in simple interest when he invested this much for 9 months. The rate of simple interest was, okay, for simple interest we know we're going to have to use this equation I equals PRT over 100. And we've been given lots of info here. He earned $1,016 in simple interest, so that's the amount of interest that was earned, 1,016, and he invested this much, so that's the principal, so we can substitute that into the equation for P. The interest rate is what we need to work out, so we don't know R, and the amount of time was 9 months, and expressing that is in terms of years, it's 9 over 12. So there we've got an equation. All we need to do is to enter it into a calculator. Okay, so here you can see we've put in the solve function and then we've written out the equation, and all we need to do at the end is to put comma and then R to let the solve function know that that's what we want to solve for. When we do that we get R equals 6.84. R equals 6.84, and R is going to be a percentage. So there it is, answer C. In question 2 we've got an interest rate of 4.11% per annum. The sum of $634 was earned in simple interest over 2.5 years. The amount invested, so that's the principal that we need to find, is going to be what? Okay, so again, I equals PRT over 100. This time, we know I is 634, and we want to know P. We know R was 4.11, and we know T was 2.5. We'll put all that over 100 and solve it. Okay, so here's the equation. The amount of interest, the principal we don't know, the interest rate, time is 2.5 years, it's all over 100, and then we put a comma P to tell it we want to know P, and it tells us 6,170.32. Okay, and that corresponds to this first answer here, A. Okay, in question 3 it says the farm brand dozen eggs costs this much, with an inflation rate expected to average 3.5% over each of the next 4 years. The dozen eggs will then cost, okay, so inflation happens according to simple interest, and for simple interest we know I equals PRT over 100. So straight away we can put in the amount of interest, or the increase in the value, will be I equals, the principal was 2.4, the interest rate was 3.5, the inflation rate in this case, and the amount of time was 4 years. Okay, so we can work out the increase in the value of these eggs that cost $2.4 now. That'll be I. Let's work out what that is. Okay, so here's the equation that we put into the calculator. We didn't need to put the solve function because we were trying to find the thing that's on the other side of the equation, the I equals bit, so it's all set up. And we got 0.33 was the amount of interest, or the increase in the value of the principal. So 0.336. Now that gets added on top of this. That's the increase in the value. So if we add 2.4 to that, we'll get 2.736, which we can round to 2.74. That's going to be the value of the eggs after 4 years. And we can see that that's very close to this one here, D. Yeah, I guess they've rounded it up to 2.75 because, you know, it needs to be a multiple of 5 cents because that's the smallest amount of money you can have. So you can't have 2.74 as the value of something. Alright, let's move on to question 4. Okay, in question 4, which says we've got an investment of $12,000 at 6.15% compounded quarterly to reach $15,000, and we've got to work out how long it will take. Okay, so in question 4, we need to use the compound interest calculator, and we've been told the interest rate is 6.15, the initial investment or principal was $12,000. We've got to make the future value negative, because that's the way the calculator likes it, and put in 15,000 that was told to us, and it's compounded quarterly, so these are both got to be 4. And then we calculate n, and we find out that it's 14.62. Now note that this is not the number of years, it's the number of installment periods, or it probably would be better if it said the number of compounding periods. Okay, so compounding periods 14.62. Now, if it was compounded quarterly, then that means there's going to be 4 compounding periods per year. So if we want to turn this into years, we'll divide it by 4. There's 4 compounding periods per year. And then we'll have the number of years. So if we put in that number there and then divide it by 4, we get 3.65. 3.65, and since we have to make it a whole number, we'll round it up to 4 years. So the best answer is B. It'll take 4 years to turn that amount into that amount. Okay, in question 5 it says a sum of $5,000 is invested for 2 years at this rate and it's compounded quarterly. The value of the interest at the end of the term will be what? Okay, so this is compound interest again. We'll use our compound interest calculator. So we're investing it for 2 years and it's compounding quarterly. So the number of compounding periods will be 2 times 4. And the interest rate is 4.75. The present value is 5,000. That's always 0. And the future value is what we're trying to calculate. And this is already set to 4 times per year, which is what we want for compounding quarterly. So we've just got to calculate FV, and it says it's going to be $5,495. So that's going to be the future value. And the question actually asks, what's the value of the interest at the end of the term? So this is what the new value, the total value of the investment is, interest plus principal, but we're only interested in the 495 bit. So the answer is going to be A. Okay, we've got, it says that our current household income is this much per annum and grows at the rate of 6% per annum. With this rate being constant, the number of years required for the household income to reach this amount is... Okay, in question 6 it says the current household income is this much and it grows at 6% per annum. With this rate being constant, the number of years required for the household income to reach this will be what? Now, it really would be helpful if the question said whether it was simple or compound interest, but since it doesn't, we're going to have to try both and see which one gives us the right answer. Okay, let's try the compound interest one first. If we put in these values into the compound interest calculator, N we don't know, I is 6%, PV is 61,800, and the future value is negative 100,000. And we've got to make PY and CY both 1 because it doesn't say compounding periods other than yearly, so we'll just make it yearly. And then when we calculate N, we get this value here, 8.25 years. Now, since we need to get up to 100,000, after 8 years, it's not going to get us there. So we're going to need a 9th year. That's this extra 0.25, but it's only part of the 9th year, but we have to round up. We have to round it up. We can't round it down because 8 years won't get us to 100,000. So we have to round it up to 9 years, which would suggest it's that one. The other way to calculate this would be to do 100,000 the other simple interest way would be to do 100,000 minus 61,800, which gives us the amount of interest, or the amount of increase, is 38,200. And if we put that into the calculator, if we change that to 38,200 and then calculate for simple interest, then we get 10.3 years, which if you round it up would give us 11. Okay, so really the question should say whether it's simple or compound interest, because otherwise there's no way to determine which one the correct answer is. But it's actually compound interest is the right one in this case. They really should have put that in the question though.